Hi, my name is Mykyta Chernenky and this is a CS 499 Honor Seminar presentation. The topic of my presentation is self-driving robots. In this presentation, I will talk about the different types of self-driving robots. I'm gonna cover the 5 levels of autonomous driving. Since we are dealing with the artificial intelligence, I'm going to bring up the difference of weak and strong AI. I'm also going to talk about the Turing test and the Chinese room test, which allow us to identify which AI we are dealing with. I will talk about the different types of artificial intelligence, such as specific AI, machine learning, and deep learning, which is based on artificial neural networks. I also made a little project of my own, which is an Arduino-based self-driving car. So I'm gonna talk about this project. I will show you the diagrams, the algorithm, and the code I have used. And I'll show you a short video of my project in use and talk about the limitation and the future improvements for my project. I will also cover the advantages and disadvantages of each type of artificial intelligence. So if you were to make your own self-driving robot project, you would know which specific type is more suitable for your project. So for example, if the task of your project is very simple, you may want to use a specific AI, but if it's more complicated, you may want to use something like machine learning or deep learning depending on the complexity of your project. Okay, let's get into the presentation. The popularity of self-driving robots is growing at an exponential rate. There are different fields in which we use self-driving robots, such as housekeeping, delivery, military, logistics, inventory management, and automobile. All these robots have different complexity levels. The complexity level of a self-driving robot depends on the tasks they perform. As you may have already guessed, the simplest robot of all of this would be the vacuum cleaner. It only relies on the ultrasonic sensor to avoid the obstacles. It follows a simple algorithm which basically consists of a few if statements. It basically keeps on going forward until it finds an obstacle, in which case it will turn around and continue on. Amazon Prime Delivery Bot is a more complicated version of a self-driving robot. Not only it uses sensors to avoid obstacles, it also knows exactly where it's going. It uses an inner GPS system to move from point A to point B, which would be the warehouse, for example, to the customer's house to deliver a package. Logistics and inventory management robots also rely on a sensors and GPS system to move around, but they also carry out secondary tasks such as restocking and pricing the merchandise. Military robot is far more complicated form of a self-driving robot. Not only does it need to drive and be aware of its surroundings, it also uses various recognition patterns to recognize enemies, allies, and other military equipment. But the most complex form of a self-driving robot is the automobile. The self-driving cars use the most innovative AI technology. They use various sensors and patterns to drive safely and avoid collision. As of today, there are 5 different levels of autonomous driving, which I will talk about in a second. Okay, let's talk about the 5 levels of autonomous driving. The Association of German Car Manufacturers, VDA, define these 5 levels quite differently. So let's talk about level 0, which is a car that is driven by a human without any driving assistance. The only type of assistance we get at level 1 is lane departure warning system and blind spot monitor. We don't have any actual driving assistance. In level 1 we have assisted driving, but the driver has to constantly drive by himself and be aware. Examples of level 1 autonomous driving are adaptive cruise control, park steering assist, and lane keep assist. As for level 2, which is partly autonomous driving, the car is driving by itself and the driver has to be constantly monitoring, for example, Tesla Autopilot. So technically we have got the car that drives itself, but there needs to be a human that constantly watches. In level 3, which is highly autonomous driving, where the car is driving completely by itself and the driver must only intervene in a specific time when the situation requires it. This could be confined to a specific situation, road type, road speed, or conditions. Example of that can be Audi's traffic jam pilot. By the way, I'm gonna stop here for a second because this is how far we got. We have only got to level 3. Level 4 and 5 are going to be in the future. Hopefully in the nearest future, not very far. So level 4 is fully autonomous driving, which is defined by a car driving completely on its own. Examples of level 4 are autonomous city driving and valet parking. In level 5, however, we have got completely driverless autonomous driving. On this last level, a car is able to drive even without a driver, under all the conditions it has to deal with. Examples of level 5 are driverless city and highway driving. Let's hope in the nearest future we will have completely driverless and autonomous buses that get passengers from point A to point B. There exist two types of AI, strong AI and weak AI. Many people have compared the conscious mind to a computer program. John Steele put it as the mind to the brain as the software is to hardware. Now there exist two opposing arguments for this, the strong AI and the weak AI. What is strong versus weak AI? So while strong and weak AI might sound like very objective technical terms, they're actually a little subjective. According to strong AI, the computer running the right program would be intelligent and have a conscious mind just like ours. But how can we tell if a computer really has an artificial intelligence? A strong AI should be able to reason, solve puzzles, make judgments, plan, learn, communicate. Strong AI should have consciousness, to have subjective experience and thought, self-awareness, sentience, which is basically the ability to feel perception or emotions, and sapience, the capacity for wisdom. While a weak AI appears to mimic the human mind, but it's actually only acting like it's thinking and can generally only perform a specific task. So while we haven't created a truly pure strong AI, there are many different artificial intelligence systems that are strong in some areas and weak in a lot of other areas. For example, let's talk about the Amazon delivery bot that we have mentioned before. So the Amazon delivery bot is fully autonomous. It delivers Amazon packages to the customers. You could say that it has a strong artificial intelligence when it comes to doing the job, because it mimics a human ability to move around and deliver packages, and sometimes it even surpasses a human ability as it uses a GPS navigation system and it always finds the shortest path to the customer's house, while humans make errors and could take longer to deliver the package. However, this same self-driving robot can't make any judgments outside of the scope of his task. It cannot solve puzzles and it doesn't have the human consciousness. But how do we test this? The Turing test is a test of machine's ability to exhibit intelligent behavior equivalent to or indistinguishable from that of human. To pass this test, a person A must hold conversations with person B and the machine, unaware of which one is which. If the person A is unable to distinguish the machine from the person, then it has passed the Turing test. The second argument is weak AI. According to weak AI, computers can only simulate the mind. They may simulate real intelligence, but however good they are, they cannot create a real mind or real consciousness, but only as if consciousness. John Searle supports weak AI with his famous Chinese room thought experiment. Suppose a man is sitting in a room with instructions on how to respond to certain Chinese conversations. Without any actual translations, a Chinese speaker outside the room passes notes back and forth under the door. As far as the person outside is concerned, they're holding a conversation with somebody fluent in Chinese, thereby passing the Turing test. However, the person inside the room does not really understand the conversation, simply simulating it. So the Turing test is simply not a good measure of artificial intelligence. Like in our case, we are talking about the autonomous cars, self-driving robots. There's no way we can use Turing test or the Chinese room thought experiment to measure the artificial intelligence. However, the self-driving robots we are dealing with, they may act like humans, but they don't actually have the human consciousness. Let's talk about the three concepts of artificial intelligence. The artificial intelligence, machine learning, and deep learning. To understand how they relate to robotics and the data science, let's talk about each one of them separately. So what is the artificial intelligence? It is simply any code, technique, or an algorithm that enables machines to mimic, develop, and demonstrate human cognition or behavior. In relation to the previous slide, this is considered to be weak AI because it can only do a specific task, it can only follow one algorithm, and doesn't actually have the human cognition, so it cannot make any reasoning like humans. To transition from weak AI to strong AI, the machines need to learn the ways of humans. The techniques and processes which help machines in this endeavor are broadly categorized under machine learning. But first, what is machine learning? So the machine learning is a subset of artificial intelligence. It's getting computers to perform tasks without being explicitly programmed to do them. Machine learning is done in two ways. It can be supervised or unsupervised. In supervised learning, machines learn to predict outcomes with help from data scientists. However, in unsupervised learning, machines learn to predict outcomes on the go by recognizing the patterns in input data. So they don't actually need a supervisor, which would be a human, to tell them what to do. The machine can figure it out by itself. When machines can draw meaningful inferences from large volumes of data sets, they demonstrate the ability to learn deeply. Deep learning requires artificial neural networks, which are like the biological neural networks in human. These networks contain nodes in different layers, which are input layer, the hidden layers, and the output layer. They're like biological neural networks in humans. These layers are connected and communicate with each other to make sense of large-size input data. Deep learning is a subset of machine learning, which in turn is a subset of artificial intelligence. The three technologies help scientists to interpret tons of data, which can be helpful in research of robotics or data science. Okay, and now it's time to talk about my project. I'm super excited for it. So, as you can see on the picture, it looks good. So here's a component list. So I have the Arduino board, the motor driver shield, the USB connector cable, 4 wheels, 4 motors along with the wheels, the servo motor in front, the ultrasonic sensor, the jumper wires, the battery holder, and the plastic base which holds everything. So as you may see in the front, I also have the 3D print version of the ultrasonic holder that I was able to find online. That helped me a lot because I could not use regular glue to stick it onto the servo motor. So as for assembling, I only used soldering iron, regular glue, and some tape. So it was pretty simple actually to assemble, and the project overall was not hard to do. So let's get into it. So here's the circuit diagram. So as I've said before, we use the motor driver shield, which will basically send current to all your motors. So instead of 9-volt battery, however, I have used 6 AA batteries. So I thought it was a better option because my 9-volt battery died and I had the battery holder for 6-pack. So I used it instead of this. This is my initial circuit. So we have 4 motors, the servo motor and the ultrasonic sensor. I have removed the switch because we don't need it. Like I said, I have got rid of the 9-volt battery, so disregard the switch and the 9-volt battery, but everything else is the same. You basically connect the motors to pins and connect the servo motor and ultrasonic sensor to serial pins. This is the code for my project. So I will briefly cover what it does without taking too much time. So in the beginning, we include all the libraries we need, which are Adafruit, the servo library, and the sonar sensor library, which is called NewPin. We define all the constants we need here. This is the initialization for the sonar function, for the motors. And let's begin. So in setup, the setup function is the one that is triggered as soon as you turn on the Arduino project. So what I do here, I basically set up my sensor so it's looking forward. I send 4 reads with my sonar sensor, and in the loop, the function that is constantly being executed when the machine is turned on, we basically set distance to the left and right to 0. And then if the distance is less than 30, and we are talking about the distance to a potential obstacle. So whenever we receive a read from the sensor, if the distance to an object is less than 30, then we stop the car, we move backward a little, then stop the car again, look left and look right. So when we look left and right, we want to see if there are any potential obstacles. So for example, if obstacle on the right is further away than obstacle on the left, we may want to go right, which kind of makes sense, and basically other way around as well. So these are the functions for looking right and looking left, which basically include reading the distance to a potential obstacle, and this is a function for the sonar sensor, which basically reads the distance to an obstacle. This is a function for stopping the vehicle, which basically releases all the motors. This is the function for moving forward. It's pretty simple. Moving backward and turning left and right. I decided to add something funny, which is a random factor. So the car doesn't really know by which angle it will rotate, right or left. So I added a random function which basically has values from 800 to 6200, which are roughly 30 to 210 degrees. That's what I was able to reckon from watching it rotate over 100 times. And this is it. So it's a pretty simple code, not many lines at all. Okay, so let's take it out for a spin. I hope you enjoyed the video. So let's talk about the limitation and future improvements of my project. So you may have noticed that my car does not detect obstacles which are too far on the left or too far on the right. So it has a very small field of view and it doesn't detect obstacles while rotating. What I mean by that is, for example, when it detects an obstacle, it backs up and starts rotating. So while it rotates, it doesn't actually use the ultrasonic sensor, because that's how the algorithm is. It's pretty simple. And then the next one is my car is super slow, and that is because it doesn't have an additional power supply. It only relies on 6 AA batteries, so it doesn't have enough power to go faster. And the last one is that my car is limited to its simple algorithm. So what I mean by that is that my car is essentially weak AI. It doesn't have any cool features. It can't think, it can't do anything beyond the scope of its algorithm. So for future improvements, for example, I could use machine learning or deep learning to use neural networks to have different data sets. So I could potentially make my car train itself. So for example, it sees an obstacle, aha, I know the obstacle is here, so the next time I don't come back here. So there's many ways I could improve the algorithm of this car, but I'm very limited to the hardware I use because Arduino does not have much memory, so neural network may not be possible with Arduino, but definitely I could use machine learning to improve my algorithm so the machine can be supervised, and I could potentially teach it and feed it some data sets, which would be very limited. Also, I could simply improve the algorithm. That would be a good improvement. And most definitely, I would need a better power supply, or better yet, add another power supply so that my car goes faster. And just so that I get a much better field of view, I would need more ultrasonic sensors. So with 3 sensors instead of 1, I would not need a servo motor because I would be able to scan the environment around the car, which would be much better. So I would have a much better field of view, so my car would not hit the shoebox like it did in the video. If you ever decide to make your own self-driving robot or any other type of AI project, here are a few tips for you. So, as I have said before, there are 3 different types of AI: artificial intelligence, the machine learning, and deep learning, which are all subsets of each other. So, the artificial intelligence is the simplest one. It only relies on the code that is written by human. It doesn't train itself, it doesn't have anything. So, the advantages of it would be it's very cheap to develop, it doesn't require training, and it requires little amount of memory. And the disadvantages are it has a very limited functionality. It cannot do anything beyond the scope of its algorithm. As for machine learning, it can train algorithm with data. A good example of the machine learning project would be face recognition. The main advantages of machine learning over artificial intelligence is it uses data sets to train, and it improves the algorithm over time. And compared to deep learning, it doesn't require much computing power. And disadvantages: it takes some time to train the algorithm. It may take a couple days, for example, for an algorithm to train to recognize faces. It's definitely more timely and costly to develop than the regular AI. It requires larger amount of memory because you have data sets. It may produce incorrect results if something has gone wrong, in which case the supervisor will have to update the algorithm and retrain the model, which will once again take some time. Deep learning trains algorithms with large data sets using artificial neural networks, also known as ANN. A good example of deep learning would be music genre classifications. So basically, if you feed your computer with a bunch of music and you classify them, the machine will be able to eventually recognize the genre of the music it listens to. The main advantage of deep learning over machine learning is that it does not require supervision, and it has a much better performance with large data sets. As for disadvantages, it takes longer time to train the algorithm, and it requires a lot of computing power, and you need a very powerful GPU, or maybe 5 GPUs stacked up together. It requires a very large amount of memory, and it's very complicated and expensive to develop. So, as you may be able to tell, my project was based on regular AI. It only had an algorithm that used sensors to find obstacles around itself. It did not train itself. So that was the main limitation of my project, is that it wasn't able to train itself and learn from its mistakes. As you may be able to tell, deep learning project would require longer time and much higher expertise to come up with a project. But if you're interested, go for it, you know? My next project would probably be focused on deep learning, so that's my goal for the next project. Here's a list of my references, and this is it for today. Thank you for watching this video, thanks for your attention. If you have any questions or suggestions, please write them down in the comment section below, and bye-bye. I'll see you in the next video.